Hi guys, so we're going to continue calculating the area of something, right? Under the graph between the x-axis and the y-axis and the graph itself. So we're going to continue calculating this area here, but this time the exercise is just asking from 1 to 2, so it's just going to be this area here. It's kind of faint, okay, so it's just going to be this part right here, all this. This thing will not be calculated, just this area here. Okay? All right, let's do it. Here we have f of x equals 4 minus x squared. So integrating that with respect to x, you got 4x minus x cubed divided by 3. And then, since this is the integral, you're going to do f of b minus f of a, which equals f of 2 minus f of 1. Because we're not starting at 0, we're starting at 1, at x equals 1, all the way to x equals 2. Okay, so putting a 2 here, you got, well, let's just put like, we're going to extend this here. I'm going to erase this thing here. I'm going to put a 12. All right, so putting a 2 here is going to be a 36 minus 8, right? And then minus, and you open a parentheses, the 1. So it's going to be 12 minus 1. So, well, actually, it's going to be 2, so it's going to be 24. Sorry about this. Okay, so it's 12 times 2, so it's going to be 24, right? Minus 2 cubed, which is 8. And then you have a minus, and then you have to do the same thing for f of 1, so it's going to be 12 minus 1. So in here you have 24, it's going to be 16. In here you have an 11, right? So 16, you got a 16 here, minus 11 is going to be equal to 5. If I didn't make any mistakes in calculation, that's it. If I did make a mistake, the semantics still the same, okay? The way to do this thing is still the same. I just made a mistake in the algebra here because I'm kind of sleepy right now. So, oh no, oh yeah, I'm sorry, I did make a mistake. I did. I forgot about this 3 here, okay? So everything is being divided by 3, remember? This is being divided by 3. This is being divided by 3, so this is also 3. Okay, now we got another situation here when we... In here, look at what we're doing, okay? I'm going to get something like that. And let's see here. No. Okay. Okay. So what we're doing here is integrating like this, right? From 1 equals to, from x equals to 1. So you got this, okay, and then you have this. You keep making these extremely thin. I'm making them even thinner, okay? But you make these extremely thin rectangles, right? And they're going to be all over here and all over and blah, 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 blah. Okay, so this is the way to integrate with respect to x. You keep making rectangles like this in the x direction, going this way, okay? But you can also integrate with respect to y, and that helps when you don't want to deal with a square root. That's the example that we're going to see next. So instead of integrating like this, we're going to integrate this way here, okay? We're going to integrate this way. You can also do that in the y direction here. We can do it. So let's do that. That's the next example. Okay. There. See? So it's asking me to calculate the area. Okay, now what area? It's gonna be this area here. Okay, you got something in here. All this area. So it's gonna calculate between the graph and the y-axis. All this thing here. Okay, this. So you see, what do you have here? You have f of y, because when you have f of x, this is the same thing as y. But when you have f of y, you have x, okay? So sometimes it's better to deal with it this way. Because you see, here we have f of y equals y squared. That means that x equals y squared. Now, if you were gonna do like y equals plus or minus x squared, you're gonna have to deal with this plus or minus, maybe restrict the domain. You don't want to do that, okay? So what you want to do is to deal with this. Now, how do you do that? Well, you're just gonna integrate the whole thing with respect to y, okay? You're gonna integrate, this is the function, right? F of y equals y cubed. So you're going to integrate f of y with respect to y. That's what's going to happen. And here you have y cubed dy this time, not dx. So what you're going to have is the integral. I'm just going to call this integral g of y. I don't know, it's just made up. Y cubed divided by 3. All right. Now, you see, you're integrating from what? From y equals 0 all the way to 1, okay? So you have to do g of 1 minus g of 0, which is 1 cubed, 1 divided by 3, 3, minus 0 cubed divided by 3. You forget about this and you got 1/3, okay? So 1/3 is the value of this thing here, of this whole stuff. This is 1/3, okay? That's this area. That's what this is. Here you have another one. Okay. You see, the book is still using the approximation method, as you use the n minus 1 squared divided by n squared. It's still using that n formula, but we already passed that. We already going the integration stuff. So you want to do the integral from 0 to 1 of f of x dx, right? So this is going to be x to the half, because you can see here that equals square root of x, right? Dx, you're going to integrate that. So it's going to be x to the 3 over 2. Divided by 3 over 2, it's 2/3. All right? Oh, yeah. Let me just finish this. From 1 to 0, or from 0 to 1. Well, when this is 0, it's just going to be 0. So when this is 1, what are you going to have? 1 to the 3 halves. Well, 1 to the 3 halves is just 1, right? It's actually this. 1 to the 3 halves is 1 cubed on the square root, okay? That's what this is. So 1 cubed is 1, and the square root of 1, it could be plus or minus 1, but you see, it's just from 0 to 1 in here, so you don't want x to be minus 1. Anyway, it's just going to be 2/3, okay? This is going to be 2/3. Now, what is 2/3 in here? Let me see if I can grab another example here. No, I couldn't find anything else. Okay, so what is going to be 2/3? 2/3, guys, is this, okay? Not this thing here. 2/3 is this stuff, this area here, okay? This is 2/3. I already showed this to you guys. I already showed that. Yeah, there's something else that I want to say. Remember that when we had, for example, let's just say that the integral of f prime of x, right, equals f of x plus c. Remember that? And then I said when you go from a to b, when you have a definite integral, it's going to be f of b minus f of a. And you go like, okay, but what about this c in here? You don't have to worry about the c because you see, f of b, okay, so let's do it. If you're going to integrate this, you got f of x plus c. So it's going to be f of b plus c minus what? F of a plus c. And then you go, this is going to become a minus, and this is also going to become a minus. So you're going to have f of b plus c minus f of a minus c. So this c here is going to be canceled by this other c, and all you have is f of b minus f of a. There's something else too that you guys have to know, is that when you reverse the limits of integration, you actually you're inverting the sign. So the integral of f of x with respect to dx from a to b equals minus the integral from b to a of f of x dx. Okay, this is just something that maybe you guys want to do it in the future. Why? Because you see, sometimes you want to add integrals, and you can do that. I mean, if the limit is the same, you can do it. Okay, but you cannot add, for example, from a to b all the way from b to a. You can't add this stuff because the limits are different. So you can invert. You can put an a here, you can put a b here, and you can change this plus sign to a minus. Now you got ba here and you have ba here, so now you can add these integrals. You can just join them. Let me see here. I already showed this to you guys. Let's make another one. Just for the fun of it, you know. We're going to integrate from 1 to 3 x cubed dx. So it's going to be x to the 4th divided by 4, right? So 3 to the 4th divided by 4 is going to be 81 divided by 4, minus 1 to the 4th divided by 4 is going to be blah, blah, which equals 80 divided by 4, which can be equals 20, right? Guys, now we're gonna, it's coming to the easy part, because sometimes it's very complicated that I have to tell you guys a bunch of theories, and it's kind of complicated to grasp things, but after a while it becomes just exercise so you guys get it, okay? Just, I don't know. Some people may find this part boring. I think it's kind of cool. X squared minus 3 dx. So we integrate that, it's going to be x cubed divided by 3 minus 3x, right? And you have to substitute this stuff. So you can substitute it directly if you want. I don't think it's a good idea though. So we're going to do this. And we're going to transform this thing to a 9, right? So you're going to have 2 cubed, right? So it's going to be, because it's 2, we're going to have 2 cubed, which is 8, minus 9 times 2, which is 18. So 8 minus 18 is going to be 10, or minus 10, right? 8 minus 18 minus 10, yeah. And now you got a minus using the 1. So it's gonna be, okay, it's gonna be 1 minus 9 is minus 8, but because of the minus becomes plus 8. And you're dividing everything by 3, so it's 1 minus 9, right? It's gonna be minus 8, but because of the minus, it's because of this minus here, guys, because you have to do, this is the integral, okay? This is already the integral. It's f of 2 minus f of 1. So that's why this minus a here becomes a plus, because of this minus here. So this is gonna be minus 2/3. Another example. Of course, if you guys don't want to make any mistakes, you better do it slowly. From 1 all the way to 4, 3, square root of x. Well, in this case, we know, well, let's just do this. It's going to be 3, this is to the half, right? So 3 over 2 times 2/3. So you're going to put a 2 here. It's going to become that. This is the integral, okay? And then from 4 all the way to 1. Let's do this slowly. So you have 2 times x, well, okay, 4. It's going to be 4 cubed, which is 64, and the square root of 64 is 8, so it's going to be that, okay? 2 times 8 minus, and then you have a 2 times whatever this is, going to be 1. So 16 minus 2, 14. Now you have the integral from 0 to pi divided by 4 of secant squared of x dx. Okay, so let's find the added derivative, or the integral of this, which is going to be the tangent of x. Remember, I just want to use the chain rule here so you guys get used to it. You're integrating with respect to x, but x is in here, it's the inner function. So actually what you have to do is to integrate the outer function divided by the derivative of the inner function. So it's tan of x, a tangent of x divided by what? Divided by dx of dx, which is the derivative of x with respect to x, which is 1. Okay, so it's going to be tangent of x. Just never forget that. Why? Because this seems obvious, but what about when it's 3x in here? What about when it's 3x squared? Okay, so it could be the secant squared of secant tangent, the secant squared of the cosine, okay? Not of x, but of the cosine of x. So you have one function inside another, inside another, inside another. All right, so tangent of x, right? And is the tangent of x 45 degrees, which is 1, minus the tangent of x as 0, which is 0, so it's a 1. I think it'll be it for today, guys, for now, right? And that's it.